Hi everybody, welcome back. This is Unit 5, Lesson 5, and in this video we're going to discuss the parts of a chemical equation, why we balance equations, and give you a couple examples of balancing equations. So think of a chemical reaction as a before and after situation. You have your ingredients, and your ingredients are everything that comes before the arrow. It is the stuff that you're going to put in to make something new. The first two times you played it, I didn't say anything. Now I'm trying to record a video for my class, so I'd prefer it if you did not do that. Well, I know, but good. It's karma. That's what karma is. It's like you're being obnoxious on purpose. Don't. Listen to it yourself. I don't want to hear it. So the stuff that comes before the arrow, you find to the left side, and we call those things the reactants. They are your ingredients in the reaction. They get used up, okay? And they go to make something new, which is the stuff that you find on the right side of the arrow over here, and those are known as products. So really, the arrow is what separates what you have before the reaction and what you have after the reaction. Okay? This is the stuff that you have before the reaction takes place. Think of the arrow as mixing, 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 and this is the stuff that you have after the reaction has occurred. Okay? And again, you need to know the names of those. So everything that you have before the arrow, those are known as your reactants. And everything that you make that is new comes after the arrow, and those are your products. Okay? So a little bit of terminology. Go ahead and finish this one. Label your reactants and your products. You'll notice in this reaction, one of the products is heat, meaning that this reaction, just to review from very early on, is exothermic. Okay? So hopefully you labeled this side, the left side, as your reactants, and this side over here as your products. Now, the whole point of this is that the law of conservation of mass states that matter cannot be created nor destroyed. So if you have 8 atoms of carbon on the left side of the arrow, then you must also have 8 atoms of carbon on the right side of the arrow as products. Total. Okay? You cannot have atoms created nor destroyed, and so what we are going to do is balance equations if this is not true. If you don't have the same numbers of atoms on both sides of the equation, you will need to balance them. Okay? The only thing you may change when you balance an equation is a coefficient. You can add them, you can remove them, you can change them, but that's the only thing you can do when you balance an equation. Oops, let me change. You may not alter subscripts. And coefficients, as we talked about in class today, are big numbers that come in front of the formula. Okay, so here, 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 and here. Remember, if there is no coefficient, it's a 1. Okay, that's all you can change. You may not change subscripts. And subscripts, if you are confused, are the little numbers. Right? This is a subscript in the formula. You cannot change those because then that would change the identity of the compound. Okay? For example, H2O is water, but if you change the subscript of oxygen and made it H2O2, that's hydrogen peroxide. So you are not allowed to manipulate those little numbers. You are only allowed to change the big numbers that come in front of the arrows. That is how we will balance an equation. We will either add, change, or remove the coefficient so that we make the total number of atoms on the left equal the total number of atoms on the right. So when I am balancing an equation, since I want to separate the left from the right, I draw a wall where my arrow is, and I list every capital letter as an element. So I have Mg, I have H, and I have Cl, capital C, lowercase l. I copy that list in the same order on this side. Now all I'm going to do here is like we did in class today, I'm going to count. I'm going to see maybe this is already balanced. Maybe I don't have to do anything. So I'm only going to count atoms. And remember, the total number of atoms is equal to the big number, the coefficient, times the little number for that element, the subscript. So it's pretty easy to count, S-C-R-I-P-T. It's pretty easy to count magnesium's number of atoms over here because its coefficient is 1 and its subscript is 1. So we only have 1 atom of magnesium on the left. Hydrogen, coefficient 1, subscript 1. We only have 1 atom of hydrogen on the left. And chlorine, the coefficient's 1, the subscript's 1. We only have 1 atom of chlorine. This down here is basically our scratch pad, or where we're working. When we balance, you have to add, change, or remove big numbers up here. If we go to the right side, the coefficient here is a 1, magnesium subscript's a 1. So we have 1 atom of magnesium. Over here, the coefficient's 1, the subscript's 2. We have 2 atoms of H. And for Cl, our coefficient's 1, our subscript's 2. We have 2 atoms of Cl. So it appears that we have created matter. We started with 1 atom of hydrogen, we ended with 2. You violated the law of conservation of mass. You are not allowed to do that. If you had 1 going in, you got to have 1 coming out. Okay? Or if you had 2 going in, you can't take atoms away really unless you change a coefficient. If you had 2 atoms of H coming out, you really need to have 2 atoms of H going in. So when you go to balance, you pick an element that is not balanced that would be easy to fix. So H. And you go to the side with less, and you're going to make more. We're going to make 2 atoms of H over here. Okay? Now remember, how we get our atoms is our coefficient times our subscript. Right now, our subscript is 1, and our coefficient is 1. That's how we're getting a total of 1. We need 2. You can't change the little number, you can only change the big number. So the next choice that you could do is put a 2 here. Then you would have 2 times 1 hydrogen. Again, I have to change my scratch pad because now I have 2 atoms of hydrogen. But remember, when you put a 2 here, just like we did in class, it gets distributed to both the H and the Cl. So before I move on, I'm going to change the other element that I affected. I used to have there 1 atom of chlorine. When I put a 2, 2 times 1 gives me now a total of 2. And in balancing my hydrogens, I also balanced my chlorines. Okay? So all that you may do is put a coefficient in front of somebody to make them equal. Okay? And again, remember these guys that don't have coefficients, they really have 1s there. Okay? That's it. That's all you do. So really balancing equations is a matter of trying something. If it doesn't work, erase it and try something else. But you'll learn particular hints along the way. Let's do another one. Draw your arrow, list, and count. Copy that list in the same order on the side. So aluminums, there's 2 of. Oxygens, there's 3 of. Aluminums, there's 1 of. Oxygens, there's 2 of. It's also a good idea to think 1 step ahead. What I mean by that is it's pretty easy right now to fix my aluminums. I have 2 over here. How can I get 2 over here? Well, you might not want to do this, but we could put a 2 there. 2 times 1 gives you 2 aluminums. But if you think 1 step ahead, your oxygens are not equal. You have 2 over here and 3 over here. That's kind of a problem, okay? because in order to fix my oxygens, I'm going to change my aluminums, which is going to mess this up. One tool you could use would be to use least common multiple. So let me go back to the aluminum. Let me go back to where I was, because I know I'm not going to need a 2 there, because I'm going to change my aluminums anyway. What is the least common multiple between 3 and 2? It's 6. So let's make a total of 6 oxygens on this side and 6 oxygens on this side. So in order to get 6 oxygens over here, again, you can't put a coefficient in the middle of a formula. You can only put it in front. What would you need to multiply by the 3 by to give you 6? Put a 2 there. That changes your aluminum. See? That's why it wasn't a good idea to start with aluminum. 2 times 2 gives you 4. 2 times 3 gives you 6 oxygens. Now go and fix. Okay? I can fix my aluminums. Stick a 4 here. 4 times 1 gives you 4. I can change my oxygens. I need 6. Put a 3 here. 3 times 2 gives you 6. Okay? Now we are balanced. So that time we had to put coefficients in front of everybody. So this balancing equations is kind of like a puzzle that you have to solve. I'm going to do one more, and then I'd like you to finish the others up for class tomorrow. So we draw a wall. We list, and we count. 2 carbons, 6 hydrogens, 2 oxygens. 1 carbon, 2 hydrogens. Now look at O. O is what I call funky because it's present in the first compound. So I'll label there's 2 oxygens in the first compound. Plus, there's 1 over here. 1 oxygen in the second compound. Do not just put 3. If you do, I'm going to mark you wrong. Okay? That adds, it equals up 3, but don't just put 3. Because if you put a coefficient here, it only changes your oxygen in the first compound, not the second compound. Okay? So it's very important that you list these separately and you just add them up to get the total. All right. Let's find somebody, save the funky for last. Save oxygen for last. Find somebody that's not equal that would be easy to make equal. So there's 2 carbons on the left and 1 on the right. Go to the side with less carbons and make it equal the side with more. How can I get 2 carbons over here? I would need to put a 2 in front of carbon dioxide. And again, that gets distributed. So before you move on, make your changes. 2 times 1 carbon gives you 2. 2 times 2 oxygens gives you 4. Time out, phone. Okay, we're back. So sorry I had to pause you, but we had just changed 2 to 2 carbons to give us 4 in the first compound now. Now 4 plus 1 that we have there gives us a total of 5. It is very important to be thoughtful, methodical, and neat when you balance equations. So I balanced the carbons. They're done. Save the funky for last. I'm not even looking at the oxygens right now. I'm going to go to the hydrogens next. I have 6 on the left, so I'm going to make 6 hydrogens over here. What can I multiply this 2 by to give me 6? You might say 3. Very good. So you put a 3 here. 3 times 2 gives you a total number of hydrogens of 6. That also changes your oxygens in the second compound. 3 times 1 give you 3. 4 plus 3 give you a total of 7. Okay? So now our hydrogens are balanced. And I don't want to mess with this. I don't want to do anything here. And then I don't want to mess with this because then I'd have to go back and change those. So now the question is, I have 7 on the right and 2 on the left. Is there a number that I can multiply 2 by that would give me 7? Even if it's not a whole number. Right? 2 times 3 is 6. 2 times 4 is 8. So if we go in between 3 and 4, we'll get 7, right? I can put a 3.5 here. 3.5 times 2 would give me 7. Oops, sorry. Wrong thing. Don't do that. goes down here, see? 3.5 times 2 oxygens would give me 7. And then my oxygens are balanced. The problem is whenever you balance equations, you want the lowest possible whole numbers. And 3.5 is not a whole number. So we need to do something about that. How can we get 3.5 to be a whole number? We could double it. If you doubled it, you'd get 7. But if you double that, you have to double everybody else or you won't be balanced. So when you use a half to balance your equation, you then take all of the coefficients and multiply them by 2. So that would give you 2 C2H6 plus 7 O2 goes to make 4 CO2 plus 6 H2O. And now you are balanced. And if I'm just going to prove this. You don't have to necessarily write this down, but just take a look at it. If I go and recount, 2 times 2, 4. 2 times 6, 12. 7 times 2, 14. 4 times 1, 4. 4 times 2 in the first compound is 8. 6 times 2, 12. 6 times 1 is 6 for a total of the side of 14. And you can see by doubling everybody, remember you got to double everybody. This is a 7, this is a 2, this is a 4, this is a 6. You still remain balanced, and now your coefficients are lowest possible whole numbers. Okay? For tomorrow, I'd like you to give this a try. It's all about trying. I could do it till I'm blue in the face, but you have to be able to do it. So try the next one, the SE plus O2 goes to make SeO3. That's in your notes. And I think there might be one more in there. Let me just look. Yeah, and also try this last one. So there's 2 that I want you to try in your notes. A real good hint, one that works all the time in Regents chemistry, is if there's no obvious starting place, you have no idea what to do. If you put a 2, I don't know that this is the case, but if you put a 2 in front of the first element or compound in the equation and then try to balance it from there, most of the time that will work. But only use that when there's no obvious starting point, okay? When you are absolutely 100% stuck. And don't be afraid to scrap things and start over, okay? Try more than once if you have to. Have a great night, everybody. We will see you tomorrow. Bye-bye.